Consider the following example. We want to write negative square root of 3 plus I in polar form. Now that means we want this to be in the form r times the quantity cosine theta plus I times the sine of theta. Now let's graph this in the complex plane. We know that the real part is the horizontal axis and the imaginary part is the vertical axis. So it looks something like the following. And what we want to do here is kind of draw a quick right triangle. Looks something like that. That's theta prime right there, which is hard to tell, but we'll get back to that. All right, first thing we need is r. We need r to be of the form square root of a squared plus b squared, where a in this case is negative square root of 3, and b is 1. So let's write that out here. Negative square root of 3, the quantity squared, plus 1 squared. All right, so if we simplify that thing out, we get our favorite number here, the square root of 4, which equals 2. So the radius in this particular problem is 2. Now all we need is theta, and we'll have it. We have a nice little formula that says the following. The tangent of theta is equal to b all over a. And for our problem, b is a positive 1, and a is negative square roots of 3. So we know our inverse trig relationship, so we'll take the inverse tangent of both sides. If we take the inverse tangent of negative 1 all over the square root of 3, then we can find our angle. And most often, if your calculator is in degree mode, you're going to come up with a number of negative 30 degrees. Now that doesn't make much sense here since we're in quadrant 2, so let's find the reference angle for that. We know that theta prime, as I have written here, is equal to 30 degrees. And so in the second quadrant, we come up with an angle, theta, equaling 150 degrees. And writing that in terms of radians, we would have 5 pi 6 radians. Now that we have our values, let's write this in correct polar form. Remember, we want something in the form r times the quantity cosine theta plus I sine theta. So z can be written as follows. 2 times the quantity cosine of 150 degrees plus I times the sine of 150 degrees. So this would be polar form using degrees. Now let's write that using radians. It would be 2 times the cosine of 5 pi 6 radians plus I times the sine of 5 pi 6 radians. So what we've done then is we've taken the point negative root 3 plus I and written that in polar form.